Okay guys, in this lesson we're going to be doing our Unit 12 exam review for organic chemistry. Number 1 asks, which organic compound is a saturated hydrocarbon? So saturated hydrocarbons are ones that contain only single bonds and whose name will end in -ane. So of course the best answer choice for number 1 is choice 4. For number 2, the multiple covalent bond in a molecule of 1-butene. First of all, I would point out that a butene molecule has 4 carbons, and because it ends in -ene, then I also know it has at least 1 double bond, with other bonds being single. And then you have to have 4 bonds for every carbon. And so there's that. And the question just asks about that multiple bond, like what it is and what's inside it. So the best answer choice there would be a double covalent bond, and a double covalent bond would have 4 shared electrons because there's actually 2 pairs of electrons in a double bond. Number 3, which formula represents propyne? To begin, prop will give you the beginning of the formula C3, and for the number of H's we need to follow the general formula for alkynes, which is CnH2n minus 2. So let's double the 3 to get 6, and then we'll subtract 2 to get 4. And that means the formula for propyne is C3H4, and choice 1 is our answer. For number 4, what's the total number of electron pairs that are shared between 2 carbon atoms in a molecule of ethyne? So that's what ethyne would look like, and the 2 adjacent carbon atoms would have 3 pairs of electrons between them. Which element must be present in an organic compound? According to the regions, that would be carbon. Number 6, the compounds of CH3OCH3 and CH3CH2OH are isomers of each other. Isomers are 2 molecules that have the same molecular formula but different structures. And you can tell by the condensed structural formulas here that they must have different structures. This one appears to be an ether, whereas this one appears to be an alcohol. But I would like to point out that they do have the same molecular formula. So CH3OCH3 is really a C2H6O. And the other guy, the CH3CH2OH, that's also C2H6O. So I'm just proving that they have the same molecular formula. But in any case, that would be also our answer. These 2 guys have to have the same molecular formula. In number 7, we have this beautiful structure here. It seems to have 5 carbons and 12 hydrogens. So it definitely is pentane. But what we're asked to do is to draw a structural formula for an isomer of pentane. So remember, whatever we do, it has to have a different shape, but it must have 5 carbons and 12 hydrogens. So there are a couple of examples I can think of right away, and I'll try to give you the least weird example first. So my least weird example would be a 4-carbon backbone and a 1-carbon attachment. So that's my 5 carbons, and the 12 hydrogens are going to come in here. So there's 3, 5, 6, 8, and 11. I think I've counted wrong. 3, 4, 6, 9, 12. Okay, yes, it is 12. So this is C5H12. And the other one, which is slightly weirder, is to put in your 5 carbons like this. And then you can really easily see that there are 12 hydrogens around the 5 carbons. So those are the 2 that I would consider drawing for that question. And then number 8, which of these compounds has the chemical properties most similar to the chemical properties of ethanoic acid? So I bring up table K because it also shows me an organic acid for ethanoic acid, which was also in the question. And I just wanted to point out that an organic acid like ethanoic acid always will have this COOH attachment when it's written in its condensed structural formula. So I can get rid of this now, but remember that the COOH is what is going to make us think about organic acids. So, in this question, we're asked to find a molecule who has similar properties to this molecule, ethanoic acid. So it's an organic acid, so we're looking for any molecule that ends in COOH, and that's why we're going to choose number 1. Now for this next question, we are charged with finding a molecule that has the same structural formula as a molecule named 2-methyl-3-pentanol. And the way I like to think about this one is I like to actually draw it either in my head or on paper, and then just match it up with one of the drawings in the question. So I'll start that process now. We need to draw a 5-carbon backbone because it does say pentan as the main part of the name. And I've done the pentan part, but it also has to end in -ol, and it says 3-pentanol. So I think the OH is going to have to go on carbon number 3. So I'll put the OH in now. And I think I've taken care of the -ol and the 3. But now I need to put in a methyl group on carbon number 2. So that's what you're seeing there. That's my methyl group on carbon number 2. And lastly, I need to make sure that every carbon has 4 bonds. And there she is. Let's see if we can find a molecule that looks like that. And as luck would have it, I have them already lined up as far as I can see. This looks exactly like choice number 2 to me. So I think that's my final answer. All right, so for number 10, the compound HCHO is an example of it, and it's one of the 4 choices. I'm going to write down the structural formula for this guy. So there's only 1 carbon, and all carbons have to have 4 bonds, and this carbon is only making bonds to 1, 2, 3 different atoms. So one of those atoms is going to have to do a double bond. And hydrogen and hydrogen, of course, cannot do a double bond, but an oxygen could. So the only thing that could possibly be happening here is a C double bonded O with an H on both sides. So you're going to name this meth to start with, and an, because it's all single bonds. But you're also going to end it in the suffix al, and that's because this guy is following the structural formula for the aldehydes, in that it has a double bonded O with an H on both sides. So different but similar set of skills is number 11, which formula represents a ketone. Ketones are a little bit different because they actually have an R group on both sides, whereas in an aldehyde you only have an R group on one side and the other side has to be hydrogen. This is ketones, so they have a parent on both sides of that central carbon. So the one that stands out to me as probably being a ketone is choice 3, but I can draw it to make that more clear. So the CH3 is right here, and then there's another carbon and an oxygen, which is, I'm going to assume, double bonded to the carbon. And then you have after that oxygen a CH3. So there's another CH3 here, and this would be called propanone, by the way, and it is in fact a ketone. For number 12, I'm asked which structural formula represents 1,1-dibromopropane. First of all, let's cross out everything that doesn't have a propane. So that's choice 1 is out, and choice 2 is out. 3 and 4 both have a kind of propane. But in number 12, we're asked to find a 1,1-dibromopropane. So I need 2 bromines, both of them on the same carbon, both of them on the first carbon. So that means 3 won't work because you have a bromine here and a bromine on carbon 2. But 4 will be my final answer because carbon 1 is right here, and you have a bromine on the top and the bottom of this 3-carbon molecule. So 4 is the right answer. 13, which formula represents an ether? Ethers have the following formula, ROR prime, and that O in the middle is the oxygen bridge. This would not be choice 1 or choice 2. Choice 1 is an ester. Choice 2 is an organic acid. It also would not be choice 4 because choice 4 is an alcohol. Instead, it would have to be choice 3 because ethers have the oxygen bridge in between the two R groups. So number 14, which formula correctly represents the product of an addition reaction between ethene and chlorine? First up, I would say that addition reactions are only going to happen for an unsaturated hydrocarbon, such as ethene. And in an addition reaction, nothing would actually be replaced. So you can start with the formula for ethene, which is, of course, C2H4, and you would just need to add the two chlorine gas atoms from a chlorine molecule. So we're looking for C2H4Cl2, and I found it in choice 3. Now in number 15, it actually looks more like substitution, because first of all, we're starting with a saturated hydrocarbon, ethane, and I can see that only one chlorine has been added, and it looks like we used to have 6 hydrogens, but now we have 5, indicating a substitution has occurred. So based on everything I just said, I would go with choice 3 on that one, and I'll go ahead and add in the little phrase that only saturated hydrocarbons do substitution. So for number 16, the answer is going to be, I'm letting the cat out of the bag here. The answer is going to be esterification, and that's because this product is in fact an ester. But the way that you would know that is by comparing the structure of that product to the reference table. And the ester on the reference table is methylpropanoate. It has a double bonded O on a central carbon with an oxygen bridge just to the side. And you can find those elements in the product as well. C double bonded O with an oxygen bridge. And all of that is just indicating that it's an ester. So naturally, this process would be called esterification. And in number 17, we're referencing hydrocarbons burning completely in oxygen, such as when a propane molecule is burning in the presence of oxygen molecules. You'll always get the same products, and those are carbon dioxides and waters. And that would be true for any complete combustion reaction. So the best answer choice here is 2. Number 18. Base your answer to the following question on the information below. We have esters, and one of the things they're pointing out is that these esters have interesting odors. For instance, methyl butanoate is pineapple, and ethyl methanoate is raspberry. So we need to draw a structural formula that has an odor like pineapple, and I can tell you that is the methyl butanoate. And all esters sort of have the same structure. I'll write that in. It looks like this. You always will have an R group on the left and an R group on the right, and the oxygen, double bonded oxygen and the oxygen bridge are a place where you can draw that dotted line. So you can draw the dotted line down the oxygen bridge, and the side that has the double bonded O, this side, gets the ending O8. And the side without the double bonded O gets the standard alkyl name. So following that template, we need to do the methyl butanoate. So I'll just sort of keep everything the same as in this diagram right here. So the methyl is going to be aligned against this R group. So I'll put in a methyl down there. So what I've drawn so far is what we would call the methyl, but I need to keep going because we're also going to have a carbon with a double bonded O, and that is going to be the butanoate that you can see in the question right here. So it needs to have a total of 4 carbons, and the O8 ending is coming from the double bonded O. So I've already put in 1 carbon, so I need to put in 3 more. And each one of those carbons needs 4 bonds. And we're all set. This molecule's name would be methyl butanoate. And the fact that it's an ester is coming from the double bonded O with the oxygen bridge. Now in number 19, we're asked to consider the following formula for a structural equation. And we've got a 1, 2, 3. So this is a propene. And of course I'm using the ending ene because of the presence of the double bond. and this is bromine. And it's making this saturated molecule that has 2 bromines in it. And this molecule is going to have the ending propane, but this is carbon 1 and this is carbon 2, and we have 2 bromines on those. So we're going to say dibromo, and it's on carbon 1 and on carbon 2. So 1,2-dibromopropane is this product. All right, so what type of organic reaction is this? That is definitely an addition reaction, which must take place on an unsaturated hydrocarbon like propene. And for number 20, the IUPAC name for the organic compound that reacts with bromine, well, this bromine is reacting with this compound and its name is propene. So the answer for that one would be propene. And with that, we've reached the end of this review sheet. So I really hope you learned something, and thanks for watching.